Thank you. Thank you for allowing us to present today. The goal of Rithim Biologics is to eliminate all atrial fibrillation. What is atrial fibrillation? If you have it, I don't need to tell you because you're miserable from it. If you don't have it, it's an abnormal heart rhythm that starts in the top of the heart. It's an epidemic. It increases in the elderly increasing in the United States. The projected numbers right now are about 7 million in the United States, about 50 million worldwide. It increases risk of stroke, heart failure, myocardial infarction. It's a major impact on the healthcare system, and it doesn't have a therapy that's effective at the current time. The two competing therapies are antiarrhythmic drugs and radiofrequency ablation. Antiarrhythmic drugs don't work half the time, and for the pleasure of having something that doesn't work half the time, you also have a risk 1 to 2% of the time of the drug killing you. Radiofrequency ablation kills heart muscle. If you like your heart and you like to keep it, you probably don't want to have an ablation. It also is not particularly effective. Atrial fibrillation is incredibly expensive. The US healthcare market cost is approximately $26 billion per year, according to the American Heart Association. Our solution is gene therapy. We use atrial epicardial painting. We do this with a gene transfer vector, which is a virus, and a polymer that allows us to apply the virus to the outside of the heart. You can see us doing this with a paintbrush, and with the correct transgene, this eliminates the atrial fibrillation. The product would be the virus, either for short-term atrial fibrillation, which we'll talk about in a second with adenovirus, or for the more usual atrial fibrillation, permanent expression with adeno-associated virus. We've demonstrated efficacy with 4 different transgenes at this point, and with the polymer, as I was saying. We're also focusing on delivery tools. As I was driving out here today, I heard that biopharma is taking place in Boston right now. Gene therapy is hot. The major limitation is delivery. My lab's been working on this for 25 years, and as Rithim, we've been working on it since 2016. We're focusing on the delivery technology. We've published this. We can not only do it in our lab, but we've validated other people who have no association with me can do it as well, and so it's verified both for the therapies and for the delivery technology. Our timeline starts quite a while ago. We have several different proven transgene technologies. We, as of this Friday, will be finishing our last animal in our final preclinical development study. We're working on the IND. Our goal is to get the funding and to do in-human therapy for postoperative atrial fibrillation with adenovirus starting about this time next year. We're also concurrently working on the delivery tools so that we don't have to open the chest. It's useful for postoperative atrial fibrillation, not for everybody else. Our catheter technology is being developed with an STTR grant that we have. So just to summarize, gene painting gets gene therapy into the atria very effectively. With a variety of different transgenes, it eliminates atrial fibrillation. We can do this very effectively with adenovirus in the short term. That will eliminate postoperative atrial fibrillation. That's going to be our first clinical target. We're working on doing this in the long term. We need the delivery technology. We're working on that with our catheters so that we don't have to open the chest. Thank you so much for your attention.
Sure, thank you. Great presentation. So where do you find your confidence in the animal studies being transferred over and having the same responder rate for the human clinical trial?
That's an excellent question. I mean, that's the risk with all preclinical data. That's why you do clinical trials. One thing in comparison to other gene therapy studies that I think is an advantage for us is that I have absolutely obsessed about delivery since 1994. And I've proven it both in my lab and as I was showing in other people's lab. Particularly in cardiac gene therapy, they've failed because they haven't delivered. I've worked on that really my entire professional life. There's always that risk that people are different than animals, but I have data showing cells from people are the same as cells from animals. They take up the virus. The method is transferable. When we get to the clinical trials, I'll have a better answer for you.